I have wanted one of these tapping arms for a long time, but I have never had a good reason to actually buy one. Well, I've got a project coming up that I think is going to provide a plausible excuse, so I went ahead and picked one up. I went out and bought the cheapest one that I could find, and today I'm going to share with you what I have learned. And one of the things that I've learned is that buying the tapping arm is the easy part. Welcome back to Cloud 42. I'm James. I have a project coming up that is going to require threading several hundred holes in tool steel. And there are a few ways to accomplish that. I'm planning on actually milling the part over there on the CNC mill, and I can pre-drill all of the holes that need to be tapped there. But actually threading them is another matter. That machine does not support rigid tapping, so that's out. I could potentially thread mill, and I do have some thread milling tools, and I have spent a little bit of time playing with them in the past on other machines. It's a pretty delicate operation. With a single flute tool on a machine like that, it's a pretty slow operation, and with several hundred holes, I am virtually guaranteed to deal with tool wear and to deal with tool breakage, and those tools are not cheap. Another option would be to bring the part over to the knee mill and actually power tap them, but assuming I'm going to clamp it rigidly, that means I got to locate all the holes on the DRO, and that's also going to be a super time-consuming operation. So all of that said, that provided me with the perfect excuse to buy a tapping arm, which is something I've always been curious about and have been just looking for an excuse to buy anyway. If you look at tapping machines available for sale, you will find all different kinds of machines at all different price points. But the class of machine that I'm interested in is usually sold as having a tapping capacity up to 16 millimeters. And that'll handle half-inch taps, it'll handle anything metric up to 16 millimeters, which is really perfect for what I do in my shop. Now, yes, I have seen the videos of Adam Booth pushing a 2-inch tap in his tapping arm, and that's pretty neat, but I don't really have any use for that in my shop. I've also seen the price point of those machines, and I don't have that kind of cash to spare, at least not for a tapping machine. So I'm looking for a 16 millimeter machine, and if you look around at US sources like Amazon or eBay, and you're looking for machines that are already landed in the US with the tariffs already paid, so you don't have to deal with any of that, there are a couple of classes of machine. There's one grouping around $700, maybe $750 now, and then there's another grouping that's about double that, starts around $1,400, and then they just go up from there. Now the real question is there any difference between a $700 machine and a $1,400 machine? I don't know, so I decided to go ahead and take the chance. I'll take one for the team, as it were, and we'll take a look at one of these cheaper machines and see how it is. So the one I bought for $699 from Amazon from a US supplier. At least it was an importer that already had it in the US. So it was free shipping to me, so I paid $700. They're about $750 if you go back and look at them today. I bought it several months ago. Now you can get the same machine or a similar looking machine direct from China, like from AliExpress, for less, maybe around $500. But then you have to deal with the shipping, you have to deal with any of the import charges if the seller doesn't deal with that. Yeah, I could do that, but I just decided I didn't want to, so I just ordered from Amazon, paid $700, and that's what we're going to look at today. Now, I really was not sure what I was going to get for $700, but I have to say I am very pleased by what actually showed up. This thing showed up in a pretty heavy, it wasn't a crate, it wasn't really a box. It was a cardboard box with like inch-thick walls with multi-layer corrugated cardboard, and there was actually some OSB wood in the bottom of the thing. So it was kind of a crate inside a cardboard box, all strapped together with styrofoam packing. It traveled well, and it was heavy. This thing, it's hard to describe this, but at the low end of the market, I was expecting something that would feel plastic and cheap, and that is not this. This is a solid, I think this is a cast, probably cast aluminum main frame here that's got the electronics that are inside this, the motor controllers in here, you've got the touch screen on top. We'll take a closer look at that in a minute. And we've actually got like brass or bronze bushings here on a solid ground rod for that pivot. We've got a nice pivot over here as well, and it is smooth and it is quiet. We've got the air springs on the parallel arm here, And this is, you know, it's just enough to lift it, but it moves pretty effortlessly. And the overall feel of this, I mean, I can't imagine buying anything that felt any better than this. You know, I've had a lot of machines that are pretty wobbly, and this is not that. This is nice and solid. Coming right out of the box, I put a square to the table on the head, and it is square, and it stays square throughout the motion. Just from a mechanical feel, I'm pretty impressed. I was not expecting this for this kind of price point. And you can see I've got a 1/2 inch tap here in the collet, and there's just buttons here on the inside of the handle. And you can hear it's quiet. So that's advancing the tap, and then I have it set to go faster on the reverse direction when you back it out of the hole. So you can just bring this over to a hole, hit the button, tap it in, and then run it back out. And there's a bunch of different tapping modes. We'll take a look at that in a minute. But for $700, I'm actually pretty impressed. So there's a servo motor in here and a planetary gearbox, and then the collet holder, and then the collet that actually holds the tap. Now, this particular tapping head also has joints up here that you can release, and so this doesn't have to be square and vertical. It can actually swing down, it can rotate around, you can tap sideways, you can tap at any angle, but most of what I'm going to be doing here is going to be vertical, and I actually want it vertical, so I'm just leaving it alone. And all of these fasteners came from the factory incredibly tight. I mean, incredibly tight. I thought I was going to break tools loosening them. But, you know, they came free. The fasteners seemed to be reasonable quality. It didn't strip out any of the heads. And the amount of torque I had to put into it to get them loosened, I expected to. So that's a plus. Let's take a look at the user interface. I'll power this on. Now, I had to get the camera in a very specific position to be able to actually see this screen. The contrast is not great. I probably will want to make some of my own parts to actually change the angle of this thing to make it a little bit easier to read. If you kind of lean out over it, which is where I've got the camera facing down on the machine, you can see it. It works fine, but in a shop like mine with bright lights, I'm probably going to want to change the angle of this a little bit. Now, there are a couple of modes here. They sell this as what they call a tightening machine or a torque driver for like doing assembly. And you can come in here and set your fastener class and size and the torques that you want applied. And you can actually use this as a torque wrench. I'm not actually planning on using it for that. I'm just going to use it as a tapping machine. So under tapping machine, you have a few settings here. You can set the thread, and really it doesn't care about the thread. It's just rotating the spindle, but it needs to know that so that it can apply, you know, torque protection, or it can guess the pitch and then do things like backing off every turn of the tap, things like that. So you can come in here and select what you've actually got. So I can say I've got an M12 tap in here. It's automatically selected 1.75 millimeter pitch. Now you can actually switch this over to imperial as well, but it's in metric at the moment. So if I select M10, you know, it's selected 1.5. That's actually what I'm going to tap later in this video. You have a couple of different modes. You've got high speed mode, you've got smart tracking, you've got torque protection. The smart tracking, I think it's just showing you parameters. The manual's not, you know, great. And torque protection would prevent you from breaking taps. High speed mode is typically what I use. And then you've got a feed speed and a rollback speed. And these are just in RPM, and you can set those to whatever you want. So 150 and then 312. The rollback here is the maximum speed on this particular machine. You can also put in the number of work pieces and it'll count them for you if you want. You can set the torque protection, and you can set a depth for automatic processing. If you just have this set to manual processing, then there's a button to advance the tap and a button to reverse it. So I can just hit a button and it'll go forward. I let go, it stops. Hit the other button, and it reverses at whatever speeds were set. And those are just little triggers here on the handle. And while it's running, you get a speed and torque feedback, which is, you know, cute. And then you get a little animation, and you can see real time what the depth is that you're tapping to. So it's tracking how deep it's going, which is Nice. But then you can also set it to automatic. And so I've got this automatic ordinary processing, so I can set my depth. So I've got the depth set to 10 millimeters, and if I pull the trigger, it will go down 10 millimeters, and then it'll back out of the hole. And I don't have to hold the switch, I don't have to do anything, it'll just automatically tap to that depth. So if I just hit the button and release it, it's gonna run in 10 millimeters, and then back out automatically. It also has what it calls deep hole processing, where it will periodically back the tap out of the hole to break the chip. And so the feed depth here is set to 3 millimeters, the rollback depth set to 2 millimeters. And it will repeat that until it reaches 10 millimeters depth. Now this is a little bit weird because it'll go in 3 millimeters initially, then it'll back out 2. So it'll be at a depth of 1 millimeter, then it'll go in 3, so it'll be at a depth of 4, then it'll back out 2 millimeters, then it'll go in 3 again, which will take it to 5, which isn't quite what you would expect, but this will actually process to the bottom of the hole. So we'll do the first 3 millimeters all at once, and then basically do 1 millimeter at a time, backing out 2 millimeters in between to break the chips. So if we just hit the button, it goes into 3 millimeters, backs out, into 4, into 5, 6, 7, 8, 9, 10, and backs all the way out of the hole. So it's a little bit goofy, but you can set it up to automatically, go to the depth that you want, pecking as you go. Now, there are a bunch of additional programs. You can put in a bunch of different programs if you have the same jobs you do over and over again. These are basically presets you can save. And then there are other parameters you can set about the motor direction and the transmission or the gearbox that you have in it. All this stuff comes set from the factory. You don't really need to deal with it. And then it has a little test mode. So I can pull the switches. Here's the reverse switch, the forward switch, and then I can turn the spindle and you can see the encoder feedback changing. So you can make sure you don't have broken wires or whatever if it's not working. And so most of what I'm going to be doing here is I'm going to have a few hundred holes that all need to go to the same depth. So I'll just set the depth. I'll set a pecking program that works. And if I'm using a spiral point or a spiral flute tap, I probably won't need to worry about that at all. And this should make quick work of the project that I have coming up. The collets, on the other hand, are a little bit more complicated. Pretty much all of the tapping arms in this class use collets to hold the taps. Now this size of collet is called a GT12, and this is common for machines that take taps up to about 16 millimeters. There are different sizes of these, and in fact, if you've ever seen Adam Booth show off his tapping arm, he's got giant ones that hold like 2-inch taps or even larger. So this is relatively small in the grand scheme of things, but for a machine this size, GT12 is pretty much the standard collet size that you will find. And the collet is designed and fits specifically to the shank of the tap. So the tap just goes in, it locks in place, and there's a little collet here to release it. So this is sized both to fit the round shank of the tap and the square. If you look down in there, you can see there's a square drive section in the back, and then up here in the front, you can just see there are 3 little ball bearings that stick out the sides of the round portion, and those grip on the shank so that it will go in and won't come out unless you actually press on the collar, and then the square drive end transfers the torque to the tap. Now this collet also has a clutch in it that's adjustable. You can see the pin spanner holes in the top there. You can tighten or loosen this to adjust them. I haven't bothered adjusting any of the collets that I have. They've seemed okay from the factory. The idea is that it'll prevent the tap from breaking if the tap actually jams. And again, I haven't done enough testing to see that happen. Now the good thing about taps is that the shank and square sizes are standardized. The bad thing about standards is that everybody has their own. There are 4 different primary standards that you'll see for tap shanks, and then there are collet sets that are designed to fit taps for all of those different standards. The main global standard is called ISO, and that's what most of these machines come with. But as far as I can tell here in the US where I am, very few taps are actually available that have ISO size shanks. Most of the taps that are sold in the US are ANSI, So that's the second standard, or ANSI. There's also JIS, which is a Japanese standard, and that's used for Japanese taps. It's also used for a lot of taps from other Asian sources. And then there is also DIN, which is German. And I have not yet encountered a DIN standard tap where I live. But the global supply chain being what it is, I have encountered ISO, ANSI, and JIS taps, and it's very difficult to tell when you order from sources like Amazon here in the US exactly what you're going to get. Now, the vast majority of the taps that are in hardware stores or that you just buy from US sources that I've run into are ANSI, but I've got a few that are ISO and I've got a few that are JIS, so I ended up having to buy all 3 collet sets in order to get what I need. I've been told by people in Germany that everything they have there is DIN. You just buy the DIN set and you're golden. That would be awesome. I also buy inch and metric drills, so, you know, there's that. Now, if you go online, you can find charts of all of the shank and square drive sizes for all of the different tap shank standards. And so you might be able to go through your tap collection, measure what you've got, match them up with those charts, and figure out just one of these sets that will work for you. But when I did that, I found I had a mix. So I ended up getting ISO that came with the machine, and I bought an ANSI set, and then later came across some that were JIS and had to buy that set as well. And because these are not like 3-jaw chucks, you can't tighten them. They fit or they don't fit. There's a very small amount of tolerance that you could run a tap that's just with the shank that's a little bit undersized, but they really don't fit. You really need to have the right ones. Now, you don't have to make Gridfinity trays for your taps, but I did. And you don't have to make your Gridfinity trays colorful, but I did. You know, it's a smoke 'em if you got 'em kind of a situation. And having these all laid out in Gridfinity trays instead of in the actual blow molded cases that they came in is super handy, because when I pick up a tap, I don't always know what size shank it is or what standard it even is, but it's really quick and easy to kind of look around and see what it fits and find the right collet. Just takes a few seconds. You can find it, do your job, and put it back. So let's take a look at some of the taps in my collection and see what they fit. So these are my metric taps, but most of these did come from US sources, so most of these are actually ANSI taps. So that's an M3, and that fits the ANSI M3 collet, and it doesn't really fit anything else. Either it rattles or, I mean, that one's enough to grab, but it rattles and doesn't fit properly. Here's an M5, same thing, very nice fit in the ANSI collet. Here's a 3/8 inch OSG, and that is also ANSI. Here's a YG1, this is Korean, this is an M8, and once again, it's got an ANSI standard shank. Now, I do have a few metric taps in here that ended up being JIS. This is an M10 by 1.5. And this is a JIS standard shank, which is why I have the JIS collet set. And going through my pipe taps, I've got an NPT, 1/8 NPT, and these are ANSI. But I've got an RC 1/8 tapered pipe tap, and that is ISO. So almost everything I have is ANSI, but I've got enough JIS and ISO that it was worth it to go ahead and buy these. And unfortunately, these are not cheap in addition to the cost of the machine. Every collet set's probably gonna run you at least $100 unless you can find a screaming deal someplace, maybe from an Asian import source. But I ended up paying about $100 a piece for these sets. Now, there are some other styles of holders you can buy. These are ER collet holders. These are specifically ER20s with ER20A nuts. And so you can just put an ER collet in here and you can hold anything with any shank size that will fit in an ER collet. Now, you could technically use these for taps and then you wouldn't have to have all of the different size sets, but there's no clutch in this, so you're holding the tap just as tight as you're holding it with the ER collet. And presuming you have it tight enough that it doesn't slip, there will be no mercy when the tap jams. The machine will just break it off. Unless you have the torque limit in the software set, there's lots of things to protect yourself. But I think these are more useful for things like countersinks. So I've got a countersink set, and if you've just got a drilled hole, it would be pretty handy to have one of these that you can just drop into the machine with a countersink in it to chamfer the top of the hole before you tap it. So that's handy, and that's what I plan on doing, is having a couple of these with countersinks in them sitting around. And the other style of holder that I picked up are these that are for dies. So you can put a threading die in here, and just like a die holder on the lathe, this would allow you to thread onto the end of a rod. You just have to have it held vertically or held perpendicular to the tapping machine, and just like a tap, you can run this down the rod and thread it. Now, it turns out that there are all different standards for these things as well. So this is a metric M8, and this is specifically an M8 holder. Now, there are other size metric dies that fit in an M8 holder, but not all dies do. So here's I think this is a quarter. Nope, this is 3/8. This is a 3/8 24. It's about the same size die, but it's imperial and it does not fit. Now, I looked around and couldn't find die holders for imperial dies, so I was thinking about just buying these and then hard turning them to open the pocket up, but I think I'm just going to go ahead and machine some of these from scratch. It should be pretty easy to turn all the features, and we should be able to use the CNC mill to put the tabs in, so be looking forward to that in a future video. Another thing that you might consider is actually using these ER collet holders to hold drills and then use the tapping arm as a drill press. And some tapping arms are actually sold with a rack and pinion drive and a magnetic base to actually convert it and use it as a drill press, but I'm not really buying it. The spindle speed is way too slow for most drills, or most drill sizes that you would put in a collet this size. But the other problem is that it doesn't have thrust bearings, it doesn't have proper spindle bearings in it. It's just a servo motor with a planetary gearbox on it, and it's just the radial bearings in the planetary gearbox that would be carrying all of the drilling loads. So I really don't think that's a good idea unless you've got a tapping arm that really does have a different bearing setup than mine does. The tapping arm swivels on this ground steel post, and it comes with a cast base that's meant to bolt to your workbench. And this cast base has 4 convenient holes for M10 fasteners, and if they had lined up with the holes in my welding table, I would have been all set, would have put some nuts and washers on the bottom, and we would have been good to go. But they do not line up with the holes in my welding table, which means I have a couple of options. I could drill and tap the table, which I really don't want to do because that makes it hard to then move it around later. Well, I guess I have 3 options. I could just go ahead and use these welding clamps forever, move it around and use the one fastener and have these always in my way and always wonder if they're going to be strong enough or if they're going to spring, or I can make an adapter plate. So the adapter plate is the option I chose. This is a 3D printed prototype, and then you actually saw me mill this part out of steel in a previous video. And here it is. Now this table uses these tie-down bolts, or these lockdown bolts for the clamping system that have little ball bearings that expand. And so these go through the holes in the table, the ball bearings expand, and they lock into place. So I designed this plate with 4 holes that are big enough to hold those expanding bolts, so I can put those through into the table and mount this anywhere on the table that I want to. And then I've got 4 holes to thread M10 for the fasteners. Now, you'll also note that when I machined this, I did not thread those holes. Well, guess what? I have a tapping arm. Let's thread those holes. Got a vise here on the end of my table specifically for tapping. I'll just put the part in here. Of course, the orientation doesn't really matter. There won't be a lot of force on it, so it doesn't have to be held super secure. It just needs to not twist, and I need to not have to hold my hand on it while I'm working. And I've got an M10 tap. This is a spiral point tap, so it should push the swarf through underneath the part. Just snap that in the tapping arm. Now this is a little less than an inch thick, so I actually have the machine already set up for M10 1.5 to go 25 millimeters deep. So when I press the button, it'll run this through down to 25 millimeters, 20, 25, and then back it out. So I'm gonna get a little oil and let's give it a try. No drama, feels like cheating. And here's an M10 fastener. Nice. Well, that was fun. And if for some reason these anchor bolts prove insufficient, the counterbores here are large enough for just 5/8 inch screws, and we can just put those through. You know what? I think I may have mismeasured the hole circle diameter here. Man, that just almost fits. Oh yeah. Yeah, I just mismeasured it ever so slightly. Okay, I'm just gonna go open up these holes slightly. I told you I was going to go open up the holes in this thing. I didn't decide to do that because I thought that was stupid. The problem was actually with this part, so I just fixed this part and actually just drilled 4 more holes in it. And I did go back and check because I know when I machined this part, the outside dimensions were a little off, and I thought that was because of tool pressure pressing the end mill away from the part, and I'm still convinced that that is correct because this is my 3D printed prototype, and the holes in it also don't line up in exactly the same way. So I never actually tested this because this was already mounted to the table and I didn't want to take it off the table, so I was using calipers and working around the base trying to figure out what the hole pattern was, and I guessed wrong. It turns out these are M10 screws, and they are the actual square pattern here is on 2.5 inch centers. I went to the closest metric because I expected this to be metric, and I was wrong. This is 2.5 inch centers. I drilled 4 more holes in this as a 2.5 inch square, you know, rotated, and it fits now. So, well, live and learn, I guess. And what I learned is you actually measure. Don't just assume you have it figured out. And if you're trying to measure something, you really need to get into kind of an optimal situation to get a good measurement. Don't mess around with something like this because it is just going to bite you in the end. I guess measure twice, cut once. I measured once and cut twice. I have no idea where that screw went that I dropped earlier, so just grabbed another one from the drawer. And that's just only needed to keep it from flying off the top, which isn't likely to happen. Okay, that can reach almost anywhere on my table. If I needed to get back here, I would have to move it, but that's easy enough to do with just those 4 anchor screws. Nice. Okay, let's do some testing, and I'm going to do a couple of holes. These are both in mild steel. I've got an M3 tap here. We're going to do 2 holes M3 and 2 holes half 13, so kind of at the opposite ends of what I plan on using the machine for. Now the M3 is a little bit terrifying. I've got it set to go in automatically. This is a spiral flute tap that should pull the chips up and out, and I have it set to go 6 millimeters deep. And I guess let's just give it a try and see what happens. I'm a little bit scared, but let's find out. And there we go. 0 dramas. And I've got an M3 fastener here. No problem. Okay, and I've got now a half 13. I drilled these 27/64, so that should be correct. Spiral point tap should go in, and I've got it set to go a ½ inch deep. Okay, ½ inch isn't nearly enough. That barely gets past the taper, so I went ahead and set it to 1 inch, and we'll just run it back in the same hole. And again, no problem whatsoever. So those are the largest and the smallest taps that I would plan on using with this machine, and it's working great. Plenty of torque for the big one, and delicate enough for the small ones. Can't ask for more. You will be seeing more of this machine in a future video, and it will be making a lot more holes than you saw today. Is this the very best machine that money can buy? Almost certainly not. Is it good enough for my home shop here? Yeah, probably. We'll see how it holds up unless there's some kind of quality problem with it that shows itself over time. I think this is going to do everything that I need it to do. I will put links down in the video description just because I know people are going to ask, and I did spend quite a bit of time hunting down sources for the arm and for all of the different kinds of collets, so I might as well share the links and make that easier. I bought this stuff from Amazon, already landed in the US, so I didn't have to deal with any of the import charges. I'm sure you could get this cheaper if you want to deal with that and have it shipped to wherever you live. I didn't want to, so I took the easy way out, and I'm okay with that. If you enjoyed the video, give it a thumbs up. Feel free to subscribe to the channel and maybe think about supporting the channel over on Patreon. Showed this off to patrons a couple of months ago, and patrons also get access to all the files, including the drawing for that adapter plate, which I'm going to update now that I know that I had the hole pattern wrong. Thank you for watching.